An object of mass 40 kg is raised to a height of 5 meters above the ground. What is its potential energy? Okay. If the object is allowed to fall, find its kinetic energy when it is halfway down. So how is that we are able to do this? Quite simple. First thing is, let's talk about the given in terms of the diagram itself. So when we can draw the diagram and write the given at the same time, make use of that. Okay. So that's your ground. That's a big ground. Right. So we have the object over here. Midway is what they're asking, case 2. There are two cases. So we have, there are two cases. It's better we write it in case form, I guess. Okay, let's see. So we have the mass to be 40 kg and the height from here till there is 5 meters. Okay, then they're asking midway, along the midway, what is the kinetic energy? So midway is what? What is the height? Yes, 5/2 meters. Is it not, guys? Plus it will have some, obviously, kinetic energy. So here the initial velocity will be equal to 0 meter per second. Right, this is all the given. So everything is written over here. That's good enough. Now, let's talk about the working. How do we begin with? So we'll talk about case at top. What is the potential energy? Right? So potential energy is given by m into g into h. So we're going to substitute. M is 40, g is 10. Right? Acceleration due to gravity is 10 meter per second square. Into height is 5. So very simple, straightforward question. So we have this to be how much? We have this to be 408,000. 2 zeros. Yeah, wait, what am I writing? 2000. So many joule. Okay, guys. Right? Next thing. Case midway. We have to figure out the kinetic energy. See, the whole idea over here is the idea of learning mechanical energy, kinetic energy, potential energy are related, is to make such cases easy. So finding the midway kinetic energy would be tough if we go with finding the velocity and all of that. It's a bit lengthy. So what we can do is we can tell kinetic energy is mechanical energy minus what? Potential energy. Mechanical energy will remain the same. So let us make a small note of that. Mechanical energy is potential energy at the top plus kinetic energy at the top, right? So this is obviously 2000 and this is 0. So this is 2000 joule. Okay. And potential energy midway. Potential energy midway is equal to m into g into h. So in this case, right, we are substituting h to be, so potential energy at a height of 5/2, because it's at a height of 5/2. I mean, well, it's kind of obvious. So this is 40 into 10 into 5/2, right? So 20. So this would be 100 and we have 1000 joules. So if you get this questions as an MCQ, clearly we know that it would be half. But since we are trying to do it as a 4-marker question or 3-marker question, we need to show all of this calculation. Then we have the kinetic energy. Therefore, the kinetic energy in the midway is equal to mechanical energy is constant throughout the journey minus 1000, right? So if we can write the reason also as mechanical energy remains constant. Okay, so this is full-fledged answer. This is not a short version. So this is nothing but kinetic energy is 1000 joules. If the object allowed to fall, find the kinetic energy, right? So we'll summarize the answer just in case. Again, I'm writing a 3 or 4 marker answer. Potential energy at top is 2000 joule and kinetic energy midway is 1000 joule, and that would be your answer. Okay guys, so pause and have a look.